Okay, do you guys remember? Okay, shh, let's get started. What does similar mean?
Similar means they're the same shape but different sizes.
Well, yeah, actually it means they're not necessarily the same size. Ratio, the sides are proportional, right? So if this is like a 6 and 4, this might be a 3 and a 2. Okay, 6 over 3 equals 4 over 2, or you could also go 6 over 4 equals 3 over 2. The sides are proportional. What about the angles?
Also proportional.
No.
Also the same.
The same. So, similar shapes have congruent angles. Sides are not congruent necessarily, but they are proportional. 6 over 3, 4 over 2. So today we're talking about ways to prove triangles are similar. Do you guys remember how we prove triangles are congruent? Let's take a walk back down memory lane. What are SAS? This is ways to prove triangles are congruent. If you show all three sides are congruent.
No.
The one that makes a bad word is not.
It was the
Angle side.
Yeah,
And then
angle
hypotenuse
is not.
leg.
Hypotenuse leg. Did somebody say the other one?
Angle side.
Yeah, angle side. Or sometimes it's called side angle.
I like it better as saw. Yeah.
As. Anyways, okay. So to prove, one way to prove triangles are similar is if you can show all the angles are congruent. They've got to be the same shape. But actually, you only need to show two of the angles are congruent. You guys, why would that be?
Because they're at 180.
Right, if you know two of the angles are the same, then the third one has to add up to 180, so it would have to be the same also. So the first way to prove it is angle. And this is the easiest one. So we're going to do a few proofs this chapter. This is usually the way we're going to prove triangles are
Angle of angle?
Yeah.
Oh yeah, we just talked about it.
And another way is side angle side. But this does not mean the same thing as this one does. That's different. This one is prove the sides are congruent and the angle between them is congruent. This one, okay, the sides aren't going to be congruent properly, but you prove the sides are proportional, like maybe this over this equals that over that, and the angle between them is congruent. So this doesn't mean the sides are congruent, it just means the sides are in proportion and the angle between them is congruent. And then similarly, there's, actually, what was it? That was side. So the last one was side. For that one, you have to prove all three sides are in proportion. So does 6 over 3 equals 4 over 2 equal, say, 5 over 2.5? And if it's yes, then the triangles are similar by side similarity. You guys get it? Does that make a difference? You guys know what the difference between these two is? Okay. So we probably should do some odds on today. So let's turn to page 545. That is the assignment for today. Let's look at maybe just number 1. Okay. Okay, on number 1, so they give you three sides on both triangles, How can we tell if those triangles are similar? It's a yes or no question, but how can we tell?
What?
Okay. Two triangles are similar if all three sides, all three pairs of sides are in proportion. All the ratios are equal. So if we set up ratios, now, if they're gonna be proportional, it should be the smallest with the smallest and the biggest with the biggest. Did they line them up for us on all these?
Yeah.
Yeah.
Yeah, it looks like they did. So they weren't that mean. So if 3 over 12 equals 8 over 32 equals 7 over 28. If that is a yes, then the triangles are proportional, or the triangles are similar. How can we tell if those are equal or not?
Reduce them.
Reduce them is one way. Another way, if it is, you can divide all of them and see if they divide out, like 3 divided by 12, 8 divided by... Yeah, if we divide these by 3, that would be 1 to 4. If we divide these by 8, that would be 1 to 4. If we divide these by 7, that would be 1 to 4. So the answer to 1 is yes. Those would be similar triangles. If you plug all those in your calculator as division problem, 3 divided by 12, 8 divided by 32, that would be 0.25 on all of them. So that would be another way to do it. Like 6 might confuse us, but oops. On 6 it'd be like 1/5 to 1/10. What the heck does that simplify to? Well, if it's kind of like 1/5 divided by 1/10, right? And how do you divide a fraction?
Flip it.
Flip it, multiply it. So if you're doing this by hand, it would be 2. So if they all equal 2, then it would be a yes. Okay, on number 7, I know I'm jumping around here, but on number 7, are those two triangles similar? And if so, you got to say why. Like
We don't know.
angle, angle, side, angle, side.
Yes, angle, angle.
Yeah, I
Right.
don't really need to.
Number 7 is yes by angle, angle. If you just put angle, angle, the yes would be implied, so you don't have to. Some of these are no's. Some of them we don't know. Or whoops. There we go.
So would the number 8 be like the angle, the side angle?
Well, yeah, you got to make sure the sides are actually in proportion though.
Yeah,
So does 10 over 5 equal 8 over 4?
yes.
Yes. And the angle between them is congruent? Yes. So 8 would be, yeah, side angle side. And then one of those problems is actually not similar. So be looking out for that, yeah.
Side, side, side is the answer too, right?
Yeah, 1 through 6 is basically we're checking for side, side, side. So 9 could be side, side, side. But one of those is a not similar. So you gotta look out for it. 13 and 14. You guys wanna do that now or you wanna wait till the end?
Is the one that doesn't, is it congruent with the
Huh? Okay, we'll do that. I'll wait 10 or 15 minutes and we'll do that. Well, for the recording, it might be better to do it now. Okay, let's do it now. Sorry. Leave space for 1 through 12 and we'll do number 13. It's been a while. You guys remember how we did proofs?
No.
math?
8 degrees.
You tried to forget. Forget without trying, probably. What's the first line on 13 gonna be? Okay. On 13, it gives a picture of a parallelogram, and then the given says it is a parallelogram, and then it says we're trying to prove those two triangles are similar. What did I say was the easiest way to prove triangles are similar?
Angle.
Angle. Definitely the easiest. So that's kind of what we're going for. What's always my first line on my proof?
Given.
The given part. So the given is that WXYZ is a parallelogram. And it's been a long time, probably like 4 months at least, since we talked about parallelograms, but there's stuff we know about parallelograms.
So one side
There's.
is WY equals WY. I don't know if that
I'm not from the area.
Yeah, WY equals WY. That would be for proving the triangles are congruent, which we could do that. But we only need that the triangles are similar. And the best way,
would be to call angle bisector? Like angle bisector?
no, we don't know that. Actually, it would not be an angle bisector. Okay, there's stuff we know. We know on a parallelogram that these lines are parallel, right?
Yeah.
When lines are parallel, we know something about angles.
Yeah.
Which angles would have to be congruent here?
1 and 4.
1 and 4. If these are parallel, 1 and 4 are called alternate interior angles. They have to be congruent. And if these are parallel, then 2 and 3 are alternate interior between these parallel lines. So they would have to be congruent also. So, also, I know that this angle and this angle are congruent because all opposite angles in parallelograms are congruent. So there's lots of stuff we know. So I'm gonna have to erase that. What angles on number 13 would be congruent? Okay, let me start with Z and X. That's because that's the easiest one. Angle Z is congruent to angle X because opposite angles in a parallelogram are congruent. Now in my picture I call them angles 1 and 3, but what would be another pair of angles that is congruent in my picture?
Z, W, Y, and X, Y, Z.
Right. Z, okay, that'll work. Angle ZWY. The book probably stopped and said that the lines are parallel first because definition of parallelogram. So I'm kind of skipping that step. Did they do that actually? Yes, they did. Anyway, I'm skipping that step. ZWY is congruent to XYW. What was the reason? Alternate interior angles. Of parallel lines. Okay, do we have enough to say the triangles are congruent? Yes, we have angle. So I'm going to copy down the prove line. It says triangle WXY is similar. I think I forgot to mention on Friday the squiggly means similar. Kind of important. Triangle WXY is similar to triangle YZW by angle. 14. It's that picture with the triangles right there. Triangle inside a triangle. So, statement. And then it's parallel to OQ. Given. Okay, so we're trying to, you guys see what we're going for? We're trying to show that the big triangle is similar to the littler triangle. This one's kind of short. Alright, it's very similar to the last problem. If these two lines are parallel, then what? Not alternate interior. Alternate interior
There's when there's a line.
would be like here and out here, and yeah, they're corresponding. So this one and this one would be like corresponding angles, and those, yeah, those are also congruent. And same thing over. You could say the same thing over here. And you could say, why could we say the top angle is congruent?
Because it's the same angle.
Right, reflexive. Remember that line. But we only need two really, so I'm gonna use. Since this has the same reason, I'm just going to use this one. So what are these angles called?
Q
Now it can't call it angle Q because
and
there's
QO.
PQO
P.
is congruent to what?
Can we just call it angle N?
You could just call that angle M, yes, because there's only one angle that could refer to. And I'm going to kind of, it's not really cheating, but we're going to fast forward. Since it's the same reason, we're going to say the other angle. So what's the other angles?
POQ
POQ.
and angle N.
And what was the reason?
Corresponding angles.
Corresponding angles. Corresponding of parallel lines. This is a shorty, isn't it? Quick proof. So this one says triangle MNP is similar to triangle QOP. What's the reason for that?
Angle N.
What? Wasn't too bad. Easy peasy.